JCB unveils their hydrogen internal combustion engine, and Chart and Nikola move forward with a very powerful partnership. I'll go over all of this on today's Hydrogen Podcast. So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. In an article in SAE International, Matt Wolf writes, JCB debuts clean sheet hydrogen combustion engine. JCB unveiled their clean sheet hydrogen combustion engine, the 448ABH2, at ConExpo 2023 in Las Vegas. The company is touting their engine as a zero-emissions solution for construction and agricultural equipment. JCB Chairman Anthony Bamford said in a statement, "The JCB engineering team has made enormous strides in a short space of time to develop a hydrogen internal combustion engine. As the first construction equipment company to develop a fully working combustion engine fueled by hydrogen," he says he's delighted we are now able to present this technology on the international stage. JCB has a team of 150 engineers working on hydrogen combustion engines and claim that over 50 prototypes have already been manufactured at the company's UK engine plant. The prototype engines are currently powering a backhoe loader and a load-all telescope handler machine. JCB also reportedly installed one of their hydrogen engines in a 7.5-ton Mercedes truck to test its potential for on-highway use. Though JCB believes that battery electric powertrains are suitable for small machines, the company feels that energy requirements for large machines are not practical for implementation of battery-based powertrains. JCB also investigated the use of hydrogen fuel cells and unveiled a prototype fuel cell-powered excavator in 2020, the 20-ton 220X. However, JCB's studies concluded fuel cells are too expensive, too complicated, and not robust enough for construction and agricultural equipment. In a quote from Tim Bernhope, Chief Innovation and Growth Officer for JCB, "Machines powered by fuel cells are simply not robust enough to handle the rigors of site dust and G-forces. They're also too expensive for customers due to the cost of platinum and the power electronics, and are far too complicated for the market they serve." JCB states that a hydrogen fuel cell machine could cost as much as triple as its diesel counterpart. Because of these findings, the company decided to begin development on their hydrogen combustion engine as a zero-emissions fuel solution. Again, according to Bernhope, if employed in an affordable and practical way, the hydrogen is a perfect solution for our industry. He also says, "Our customers are demanding a carbon-free mobile fuel which delivers maximum uptime." He says, "We believe hydrogen is that fuel." Now, during their presentation, JCB stressed that the engineering team had gone back to first principles in designing their hydrogen combustion engine. The team reportedly studied 76 different technical papers on the subject and identified 4 key technical challenges: achieving a perfect mix of air and hydrogen, increasing the volume of air, achieving a clean spark ignition, and managing steam output. Ryan Ballard, JCB Powertrain Engineering Director, explained some of the challenges the team encountered. He says, "When most hydrogen engines were developed in the early 2000s, they were large-capacity, naturally aspirated engines. Today, engines work on lower capacities with powerful turbochargers." Ballard also explained that the operating principles behind JCB's engine is based on their research into past designs. He says, "What we noticed in earlier hydrogen engines is most people ran them in a way that produced a lot of NOx. That's really the difference to what we're doing. We run the engines at a much lower temperature and pressure, which essentially does not create NOx emissions. It's not a problem anymore." And again, according to Bernhope, "We discovered that there's a certain temperature you can burn air where it's incredibly clean. However, if you go over that temperature, it's awful. In the past, people tried hydrogen combustion using a gasoline engine with hydrogen fuel. So they're working at the wrong temperatures and pressures, and the result was awful outputs in terms of emissions and efficiency." Something that was completely new to JCB for this engine design was spark ignition. The company reportedly drew on expertise from the auto industry to integrate spark plugs into their engine and provide the right amount of spark for H2 combustion. According to Ballard, the first generation of JCB's 448 ABH2 engine features a port fuel injection system for speed to market, and because PFI systems are very robust, there's also no after-treatment system required. The 4.8-liter inline-4 engine features a single turbo with a variable vane design due to the high airflow requirements of hydrogen engines. In addition to powering their own machines, JCB stated that they are open to selling their engines to external suppliers in the future. The company also plans to address the infrastructure concerns of hydrogen refueling in innovations such as their mobile refueler that can deliver hydrogen directly to the job site that the machines are working in. Alright, so a big congratulations to JCB for seemingly unlocking the ability to mass produce efficiently hydrogen internal combustion engines. And it's important to discuss this because there are other engine manufacturers who are doing the same thing, namely Cummins. And I also know for a fact that Cummins is on the precipice of releasing large amounts of these engines to potential buyers. What I also find interesting in this article is that JCB is talking about little to no NOx emissions, which has been one of the biggest drawbacks of hydrogen internal combustion engines. The other drawback being the efficiency of using hydrogen in an internal combustion engine due to the lack of energy density per unit volume for hydrogen. But regardless, this seems to be a major breakthrough for heavy-duty on-site construction equipment. And so I guess the biggest question is now, for JCB and Cummins customers, just where are they going to source their hydrogen? Next, in a press release on March 30th, Chart Industries and Nikola execute strategic partnership for hydrogen-related equipment. Chart Industries, a leading global engineering design and manufacturer of highly engineered equipment servicing multiple applications in the clean energy and industrial gas markets, and Nikola Corporation, a global leader in zero-emissions transportation and energy supply and infrastructure solutions, via the Hyla brand, executed a strategic collaboration agreement including liquid hydrogen storage tanks, transport trailers, and the development of new mobile and modular hydrogen refueling stations for quick deployment. This agreement includes additional collaboration on the advancement of hydrogen technology for infrastructure and truck onboard fuel systems. Nikola has recently signed purchase orders with Chart for multiple liquid hydrogen storage tanks, mobile and modular refueling stations, and liquid hydrogen transport trailers to meet Nikola's needs for deploying the Nikola Tre hydrogen electric vehicles to support key customers and advance the efforts to decarbonize the transport sector. This relationship builds on a previously signed development agreement between Chart and Nikola to work together to develop innovative solutions for the hydrogen electric vehicle market. Through this agreement, Chart is providing first-of-kind, fully integrated mobile and modular hydrogen fueling stations for heavy-duty vehicles, providing a quick, deployable fueling solution with lower capital requirements. This transportable fuel station lowers the barrier to entry and is an ideal solution for smaller fleets or any intermediate and interim fueling needs. The dense liquid hydrogen storage and efficient liquid high-pressure dispense pump also lowers station operating costs. Nikola, via Hyla, is bringing comprehensive zero-emission heavy-duty trucking energy solutions to market, and each station within the Hyla hydrogen network will serve as an important step in the delivery of a broader array of hydrogen fueling solutions to the commercial trucking industry. This purchase also includes the most recent design of Chart's liquid hydrogen transport trailers, building upon 57 years of hydrogen trailer experience. This new trailer is a lightweight option designed to be pulled by hydrogen electric vehicles. In a quote from Jill Ivanko, CEO and president of Chart, "We are excited to partner with Nikola and bring first-of-a-kind, quick deployable hydrogen solutions to the market." And in a quote from Michael Loscheller, president and CEO of Nikola, "Nikola is on a mission to transform the transportation industry, and by aligning with forward-looking companies such as Chart, they are confident this ambitious goal will be achieved." He also says, We know our customers are interested in transitioning to hydrogen quickly and seamlessly. Solutions like Chart's hydrogen transport trailers will play an important part in jump-starting a hydrogen ecosystem. Now, with a range of up to 500 miles, the Nikola Tre hydrogen electric vehicle is expected to have among the longest ranges of all commercially available zero tailpipe emission Class 8 trucks, while realizing weight savings when compared to Class 8 battery electric vehicles with similar range. The Tre hydrogen electric vehicle is well suited for a variety of applications, ranging from drayage and intermodal to metro regional truckload and less than truckload to certain specialized hauling use cases. Okay, so I think this is a very smart collaboration between Chart and Nikola. Now, we recently covered the Hyla expansion from Nikola, and I thought it was brilliant. But one thing they really were missing from that vertically integrated Hyla umbrella was hydrogen transportation, and this is something that Chart does very well. And so that, with the addition of their mobile refueling systems, makes this collaboration extremely powerful. And so congratulations to Chart and Nikola on this deal, and this looks to be a very strong partnership going forward. Alright, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcast, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. And as always, take care, stay safe, I'll talk to you later. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.